In the previous chapter, measures of dispersion, we have studied different types of methods which are to be used to study the inherent characteristics and the scatterness of the various values in the given series. But now we shall discuss about correlation, and here the correlation refers to the relationship of two or more variables, and here we can find some relationship between two variables. For example, there exists some relationship between the height of a father and height of a son, price and demand, wage and price index, yield and rainfall, height and weight, and so on. Therefore, these are the variables which are to be existed some relationship. So therefore, correlation, it is a the statistical the tool which is involved in the subject in order to find the relationship of these variables. So therefore the statistical the tool or the technique which is to be used to measure or to find the relationship of two or more variables is called as the correlation. And uh, correlation measures the closeness of the relationship between the variables. So for instance, the height and the weight are correlated because both will be increasing or decreasing. So therefore it is a tool, it is a statistical the technique which is to be used in the subject statistics to measure the closeness or the closeness of the relationship between the variables. And uh, correlation is the statistical analysis which measures and analyzes the degree or the extent to which two variables fluctuate with reference to each other. So therefore correlation, it is a statistical the tool and the technique which is used to measure or to study the relation or to find the closeness or the relationship of closeness of the relationship between two or more variables. So therefore correlation means a possible connection or relationship or interdependence between the values of two or more variables of the same phenomenon is called as the correlation. And the correlation which indicates the strength of the relationship, and it is a technique which is used in measuring the closeness of the relationship between variables is called correlation analysis. So the correlation analysis attempts to determine the degree of relationship between two variables. Now, types of correlation. So correlation can be broadly classified into three types. One is positive and negative correlation, simple and multiple or partial and complete correlation, linear and non-linear correlation. ಅಂದರೆ ಇಲ್ಲಿ ಎರಡು ಅಥವಾ ಎರಡಕ್ಕಿಂತ ಹೆಚ್ಚು ವೇರಿಯಬಲ್ಸ್ಗಳ ಒಂದು ರಿಲೇಶನ್ಶಿಪ್ ಅನ್ನ ಕ್ಲೋಸ್ನೆಸ್ ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದಕ್ಕೆ ನಾವು ಕಾರ್ರಿಲೇಷನ್ ಅಂತ ನಾವು ಕರಿತೀವಿ. ಯು ಟೇಕ್ ಎನಿ ಎಕ್ಸಾಂಪಲ್, ಆಲ್ರೆಡಿ ಐ ಟೋಲ್ಡ್, ಏನು ವೇಜ್ ಆ್ಯಂಡ್ ಪ್ರೈಸ್ ಇಂಡೆಕ್ಸ್ ಆಗಿರ್ಬೋದು, ಪ್ರೈಸ್ ಆ್ಯಂಡ್ ಡಿಮ್ಯಾಂಡ್ ಆಗಿರ್ಬೋದು, ಹೈಟ್ ಆಫ್ ಎ ಫಾದರ್ ಆ್ಯಂಡ್ ಹೈಟ್ ಆಫ್ ಎ ಸನ್ ಆಗಿರ್ಬೋದು, ಆ್ಯಂಡ್ ದೆನ್ ಕ್ರಾಪ್ಸ್ ಆ್ಯಂಡ್ ರೈನ್ಫಾಲ್ ಆಗಿರ್ಬೋದು, ಡಿಮ್ಯಾಂಡ್ ಆ್ಯಂಡ್ ಸಪ್ಲೈ ಆಗಿರ್ಬೋದು. ಸೊ ಯು ಟೇಕ್ ಎನಿ. ಸೊ ಈ ಎರಡು ಅಥವಾ ಎರಡಕ್ಕಿಂತ ಹೆಚ್ಚು ವೇರಿಯಬಲ್ಸ್ ಆ ರಿಲೇಷನ್ಶಿಪ್ಪನ್ನು ಏನು ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ, ಆ ರಿಲೇಷನ್ಶಿಪ್ಪನ್ನು ಅಥವಾ ಕ್ಲೋಸ್ನೆಸ್ ಆಫ್ ರಿಲೇಷನ್ಶಿಪ್ಪನ್ನು ನಾವು ಸ್ಟಡಿ ಮಾಡೋದಕ್ಕೆ ಒಂದು ಸ್ಟ್ಯಾಟಿಸ್ಟಿಕಲ್ ಟೂಲ್ ಮತ್ತು ಟೆಕ್ನಿಕ್ ಏನಿದೆ ಅದನ್ನು ನಾವು ಕಾರ್ರಿಲೇಷನ್ ಅಂತ ನಾವು ಕರಿತೀವಿ. ಸೊ Correlation can be broadly classified into three types. One is positive and negative correlation, simple and multiple or partial and complete correlation, linear and non-linear correlation. So let us know the meaning of these types of correlation. So the first correlation, positive correlation. So this is one type of correlation in which if the values of two variables deviate in the same direction, correlation is said to be positive. It means increase in the value of one variable results in an increase in the values of other variable. So one variable value ಇನ್ಕ್ರೀಸ್ ಆದಂಗೆ ಇನ್ನೊಂದು ವೇರಿಯಬಲ್ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಇನ್ಕ್ರೀಸ್ ಆದರೆ, or if the value of one variable decreases, another variable will also decreases. ಸೊ ಈ ಥರ ನಾವು ಒಂದು ವೇರಿಯಬಲ್ ಇನ್ಕ್ರೀಸ್ ಆದರೆ ಆಟೋಮೆಟಿಕ್ ಆಗಿ ಇನ್ನೊಂದು ವೇರಿಯಬಲ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಕ್ಕಂಥದ್ದು, ಅಥವಾ ಒಂದು ವೇರಿಯಬಲ್ ಡಿಕ್ರೀಸ್ ಆದರೆ ಇನ್ನೊಂದು ವೇರಿಯಬಲ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತಕ್ಕಂಥ ಒಂದು ಟೈಪ್ ಆಫ್ ಕಾರಿಲೇಷನ್ ಇದೆ. ಅದು ನಾವು ಪಾಸಿಟಿವ್ ಕಾರಿಲೇಷನ್ ಅಂತ ನಾವು ಕರಿತೀವಿ. ಸೊ ಇಟ್ ಮೀನ್ಸ್ increase in the value of increase in the value of one variable results in an increase in the values of other variable is called as the positive correlation. And simple and multiple correlation. So when simple and multiple correlation, this is the second the type of correlation in which only two variables are studied. When only two variables are studied, it is called a simple correlation. So studying only two variables is called as simple correlation. And when more than two, three or more variables are studied, it is called a multiple correlation. And another type of correlation is that linear and non-linear. So linear and non-linear correlation means if the consistency of the ratio of change between the two variables, it means amount of change in one variable tends to bear a constant ratio to the amount of change in the other variable is called as linear correlation. Means amount of the change in one variable that it tends to bear a constant ratio to the amount of change in the other variable is called linear correlation. ಅಂದರೆ ಒಂದು ವೇರಿಯಬಲ್ ಅಮೌಂಟ್ ಏನು ಚೇಂಜ್ ಆಗುತ್ತೆ, ಇನ್ನೊಂದು ವೇರಿಯಬಲ್ ಅಮೌಂಟು ಕೂಡ ದಟ್ ಟೆಂಡ್ಸ್ ಟು ಬೇರ್ ಎ ಕಾನ್ಸ್ಟೆಂಟ್ ರೇಷ್ಯೂ. ಆ ಕಾನ್ಸ್ಟೆಂಟ್ ಏನು ಆ ಒಂದು ರೇಷ್ಯೂ ಮೇಲೆ ಏನು ಚೇಂಜ್ ಆಗುತ್ತೆ, ಅಮೌಂಟ್ ಆಫ್ ಚೇಂಜ್, ಅದನ್ನು ನಾವು ಲೀನಿಯರ್ ಕಾರ್ರಿಲೇಷನ್ ಅಂತ ನಾವು ಕರಿತೀವಿ. Now, methods of determining correlation. So there are 6 methods of determining correlation. They are scatter diagram method, graphic method, Karl Pearson's coefficient of correlation, Spearman's rank correlation, concurrent deviation method, methods of least square. So these are the various the 6 methods of determining the correlation. Now measurement of correlation. So here this is what measuring the correlation. If there is exact positive or negative, the value of one, the value of the value of any variable is 1. If there exists exact the positive or the negative value 1, it is called as the perfect correlation. Perfect correlation plus or minus 1. If the value of correlation is more than 1 and less than 0.90 and more than 1, is called as a very high degree of correlation, and if there exists less than 0.75 and more than 0.90, then correlation is called as high degree of correlation. And if there exists the value uh, less than 0.60 and more than 0.75, then it is such a type of correlation is called as the moderate degree of correlation. And if the value is less than 0.30 and more than 6 0.60, then it is called as the low degree of correlation. And very low degree is correlation is said to be a very low degree if the value is less than zero point 0.0 and more than 0.30. Then if there is if there is a zero value of any variable, then such a type of correlation is called as no correlation. And plus is equal to positive correlation, minus is equal to negative correlation. ಪ್ಲಸ್ ಅಥವಾ ಮೈನಸ್ ಒಂದಿದ್ರೆ ಅದನ್ನ ಪರ್ಫೆಕ್ಟ್ ಕಾರ್ಲೇಷನ್ ಅಂತ ನಾವು ಕರಿತೀವಿ. ಆ್ಯಂಡ್ ದೆನ್ 0.90ಗಿಂತ ಕಡಿಮೆ ಆ್ಯಂಡ್ ಒಂದ್ಗಿಂತ ಜಾಸ್ತಿ ಇದ್ರೆ, ಮೀನ್ಸ್ ಒಂದ್ಗಿಂತ ಜಾಸ್ತಿ 0.90ಗಿಂತ ಕಡಿಮೆ, ಅದು ನಾವು ವೆರಿ ಹೈ ಡಿಗ್ರಿ ಆಫ್ ಕಾರಿಲೇಷನ್ ಅಂತ ನಾವು ಕರಿತೀವಿ. ಹಾಗೆಯೇ 0.90ಗಿಂತ ಜಾಸ್ತಿ 0.75ಗಿಂತ ಕಡಿಮೆ, ಅದು ನಾವು ವೆರಿ ಹೈ ಡಿಗ್ರಿ ಆಫ್ ಕಾರಿಲೇಷನ್ ಅಂತ ನಾವು ಕರಿತೀವಿ. ಅಂದರೆ ದಿಸ್ ವಾಟ್ ದಿ ಮೆಜರ್ಮೆಂಟ್ ಆಫ್ ದಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಕಾರಿಲೇಷನ್. Now, Karl Pearson's coefficient of correlation, this is one of the most the useful the method of calculating and finding and method of assessing and finding the closeness of the relationship of two or more variables. And here Karl Pearson, a great British statistician, has propounded the formula for calculating the coefficient of correlation. That's why this method is known as Karl Pearson's coefficient of correlation. And this is one of the most the important the method of studying and analyzing and finding the closeness of the relationship of two or more variables. And this formula is based on arithmetic mean and standard deviation, and it is most widely used. So some assumptions on which the formula is based on. The first assumption on which the formula is based that the two variables are affected by a large number of independent causes, and there is a possibility of linear relationship between the two variables, and there are cause and effect relationship between two variables. So these are three some assumptions on which the formula which is based on. Now, the under Karl Pearson's coefficient of correlation, the correlation can be calculated under three methods. One is direct method, and second method is deviations taken from actual mean, and third method is the deviations taken from the assumed mean. So these are three methods on which we are going to calculate the correlation under Karl Pearson's coefficient of correlation. Now, the formula to calculate under direct method is R is equal to, so here Karl Pearson's coefficient of correlation is represented by using small letter r. So R is equal to sigma xy by n into sigma x into sigma y, where n stands for number of observations or number of items in case of individual series, and other than individual series, we say that n is equal to total frequency. And if deviations are taken from actual mean, then x is equal to x minus x bar, and y is equal to y minus y bar. R is equal to the formula here, deviations taken from actual mean. When deviations are taken from actual mean, then x is to be used as x is equal to the difference of the given values from the arithmetic or actual mean, and y is equal to y minus y bar. X is here treated as one variable and y is treated as another variable, then y is equal to y minus y bar. So the formula to calculate Karl Pearson's coefficient of correlation when deviations are taken from actual mean, r is equal to sigma xy by root of sigma x square into sigma y square. And another, when deviations are taken from assumed mean, then uh, dx is equal to x minus a and dy is equal to y minus a. Here this is another method in which correlation can be calculated. Another correlation can be calculated, and here when assumed mean is used to take deviations, then dx is to be used as represent as differences of the given values from assumed value. Dx is equal to differences for given x value, and x minus a, and dy is represented for the given y values or another set of the variable y dy is equal to y minus a. Then to calculate correlation under when deviations are taken from assumed mean, so then the formula r is equal to sigma dx dy minus sigma dx into sigma dy by n divided by root of sigma dx square minus sigma dx whole square by n into sigma dy square minus sigma dy whole square by n. So this is what the formula where we used to calculate Karl Pearson's coefficient of correlation when deviations are taken from assumed mean. So one is direct method, and another one is when deviations are taken from actual mean, and the third method is that when deviations are taken from assumed mean. Now when under direct method, when four informations are given, sigma xy n and sigma x and sigma y, then r is equal to sigma xy by n into sigma x into sigma y. When three informations are given, sigma xy, sigma x square and sigma y square, r is equal to sigma xy by root of sigma x square into sigma y square. When six informations are given, means when deviations are taken from arithmetic mean or actual mean, and when deviations are taken from assumed mean, sigma dx dy, sigma dx, sigma dy, sigma dx square, sigma dy square, and n, r is equal to, I told earlier that the formula sigma dx dy minus sigma dx into sigma dy by n root of sigma dx square minus sigma dx whole square by n into sigma dy square minus sigma dy whole square by n. Now uh, now take the first problem to calculate Karl Pearson's coefficient of correlation. And here calculate Karl Pearson's coefficient of correlation from the following data. So this example will explain how to calculate Karl Pearson's coefficient of correlation. And here when two columns are given, means when two variables are given, x is one variable and y is another variable, and here we have to take uh, we have to make the differences of all the given values of x and y from arithmetic mean. And here by here by taking deviations from arithmetic or actual mean, we can calculate Karl Pearson's coefficient of correlation. And here x is the given values is to be taken in the first column. x first column ಅಲ್ಲಿ ಬರ್ಕೊಳ್ತೀವಿ. ಫಸ್ಟ್ ಕಾಲಮ್ ಎಕ್ಸ್ಗೆ ನಾವು ಡಿವಿಯೇಷನ್ಸ್ ಅಥವಾ ಡಿಫ್ರೆನ್ಸಸ್ ಮಾಡ್ಕೊಳ್ಬೇಕು. ಎಕ್ಸ್ ಮೈನಸ್ ಎಕ್ಸ್ ಬಾರ್, ಡಿವಿಯೇಷನ್ಸ್ ಯಾವುದರಿಂದ ತಗೊಳ್ತೀರಾ? ಎಕ್ಸ್ ಬಾರ್ ಇಂದ ಡಿಫ್ರೆನ್ಸಸ್ ಅಥವಾ ಡಿವಿಯೇಷನ್ಸ್ ತೆಗೆದುಕೊಳ್ಬೇಕು. ಸೊ ಡಿಫ್ರೆನ್ಸಸ್ are deviations which are to be taken from actual or arithmetic mean is to be represented as x. x ಇಂದಲೇ ಮತ್ತೆ ನಾವು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. x minus x bar is equal to x. Now x square, y, another set of the variable, another set of the values of variable y. So to that y we have to find the differences of all given values from y bar. Y minus y bar is equal to y, and then make the square of y square, then product of x into y, deviated x into y. Now first calculate the value of actual or arithmetic mean. Sigma x is equal to divided by n. So this is the formula to calculate x bar in case of individual observation. Sigma x by n. So here sigma x is equal to 30 divided by n is equal to number of items or number of observations. 30 by 5 is equal to 5 ones are 5 6 are. Therefore the value of x bar is equal to 6. Then find y bar equals sigma y by n. Sigma y, second set of another set of the data, ಅಂದರೆ y ವೇರಿಯಬಲ್ಗೆ ನಾವು y ಬಾರ್ ಕಂಡುಹಿಡಿಕೊಳ್ಳಬೇಕು. ಸಿಗ್ಮಾ y by n equals sigma y 40 by 5. 5 ones are 5 8s are 40. Therefore the values of x bar and y bar are 6 and 8. Now complete the table from with the help of x bar and y bar. x minus x bar, x ಅಂದರೆ 6, minus ಅಂದರೆ ಡಿಫರೆನ್ಸ್ ಆರ್ ಡಿವಿಯೇಷನ್ ಫ್ರಮ್ ವಿಚ್ ಯಾವುದರಿಂದ 6 ಇಂದ. 6 minus 6 0, 2 minus 6 minus 4, 10 minus 6 plus 4, 4 minus 6 minus 2, 8 minus 6 plus 2. Now x square 0, 16, my 4 square 16 minus 2 square 4 plus 2 square 4. Now for y series, make the differences of all the values from y bar. 9 minus 8 plus 1, 11 minus 8 3, 5 minus 8 minus 3, 8 minus 8 0, 7 minus 8 minus 1. Now make the square of y. Plus 1 whole square 1, plus 3 whole square 9, minus 3 whole square 9, minus 0 whole square 0, minus 1 whole square plus 1. Now product of deviated x and y. 0 into 9 0, minus 4 into 11, minus 4 into 3, minus 12, 4 into minus 3, plus into minus minus, 4 3s are 12, minus 2 into minus 0 0, plus 2 into minus 1 minus 2. Now find the sum of xy. sigma xy minus 26, sigma y square 20, sigma y 40, sigma x square 40, and then n is equal to number of items 5. Now apply the formula when deviations are taken from actual or arithmetic mean. R is equal to sigma xy by root of sigma x square into sigma y square. Sigma xy minus 26 divided by uh, root of sigma x square 40 into sigma y square 20. Now minus 20 minus 26 by 800 is equal to minus 26 divided by root of 800, 28.284. Therefore minus 26 divided by 28.284 is 0.9192. That's what r is equal to minus 0.9192. This is what high degree of negative correlation, because more than uh, 0.90. So if there is more than 0.90, then such a type of correlation or measurement is called as high degree of correlation. And if there is minus, it is to be treated as negative. If there is positive, if there is plus, then it is called treated as positive degree of correlation. So therefore it is uh, interpreted as very high degree of negative correlation. Now take another example. So here we have to calculate Karl Pearson's coefficient of correlation from the following. X series ಮತ್ತೆ y series ಕೊಟ್ಟಿದ್ದಾನೆ. So from this first we have to calculate sigma x bar. X bar is equal to sigma x by n. Sigma x total 162 by number of items or number of observations 9 equals x bar is equal to 18. Then find y bar for y series. Sigma y by n is equal to 171 by 9 equals y bar is equal to 19. Now prepare a table to calculate correlation, and here first column x ಕೊಟ್ಟಿರುವಂತ ಏನು x series first column ಅಲ್ಲಿ ತಗೊಳ್ತೀವಿ. Now make the difference of all the given values from x bar. X minus x bar is equal to x ಇಂದ ನಾವು ಮತ್ತೆ ಅದನ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ x bar is equal to 18. So 6 minus 18 minus 12, 8 minus 18 minus 10, 12 minus 18 minus 6, 15 minus 18 minus 3, 18 minus 18 0, 20 minus 18 plus 2, 24 minus 18 plus 6, 28 minus 18 plus 10, 38, 31 minus 18 plus 30. Now make the square of x. X square minus 12 whole square 144, minus 10 whole square 100, minus 6 whole square 36, minus 3 whole square 9, 0, 4 plus 6 whole square 36, again plus 10 whole square 100, plus 13 whole square 169. Now take y series, and then to that y series we have to make the difference of all the values from y bar. Y minus y bar, y minus 19, 10 minus 19 minus 9, 12 minus 19 minus 7, 15 minus 19 minus 4, again 15 minus 19 minus 4, 18 minus 19 minus 1, 25 minus 19 plus 6, 22 minus 19 plus 3, 26 minus 19 plus 7. So like that. Now y square minus 9 whole square 81, minus 7 whole square 49, minus 4 whole square 16, minus 4 whole square 16, minus 1 whole square 1, plus 6 whole square 36, plus 3 whole square 9 plus 7 whole square 49, so like that. And then find the product of deviated values of x and y. Minus 12 into minus 9 108, minus 10 into minus 7 plus 70, minus 6 into minus 4 24, minus 3 into minus 4 12, 0 into minus 1 0, plus 2 into plus 6 12, plus 6 into plus 3 18, plus 10 into plus 7 70. So uh, this is the way in which uh, uh, we have to prepare a table before applying the formula, then find sigma xy. Sigma xy equals 431 sigma x square, sigma x square, sigma x square 338, sigma y square 598. And then now substitute the values into the formula. The formula to calculate correlation is R is equal to sigma xy by root of sigma x square into sigma y square. So here sigma xy 431 divided by root of sigma x square 598 into sigma y square 338, that is equal to 431 divided by root of uh, 598 into 338, 2 lakh 2124. Now 431 divided by square root of 2 lakh 2124 is equal to 44149.582. Now 431 divided by 449 0.582 is 0.9587. So this is what the value of r, and here from this value we can interpret that here the value is more than 0.90, then we can say that there is a very high degree of positive correlation between x and y variable, because there is plus value. If there is plus, we can say that positive correlation, and more than 9 0 point more than 0.90, then we can say that high degree of positive correlation, and the closeness of relationship which exists in between x and y variable. So this is the way in which we are going to uh, calculate the values of r under direct method uh, direct method, as well as when deviations are taken from arithmetic mean and deviations are taken from assumed mean.